going to look at an idea, greatest coefficients and greatest terms, how we can find that. It comes from a very simple idea, and that is, well, if term k plus 1 is greater than or equal to term k, then term k plus 1 must be the biggest, or the greatest term. It seems logical. A is bigger than B, A has got to be the biggest. So if we want to find the greatest coefficient in this particular expansion, so what I do is I find my general term, so term k plus 1, 20ck, the 3x will be to the power of k, so 2 will be to the power of 20 minus k. But I'm going to set up this inequality. So not only do I want term k plus 1, I also want term k. So term k then would be 20c k minus 1. 3x will be to the power of k minus 1. The two powers have to add together to give 20. So therefore 2's to the power of 21 minus k. I think that's why I always put the power on the second term first. So when I get ones like this, I can simply say, oh well, they've got to add together to give, in this case, 20. Alright, so I'm going to start with that idea. If term k plus 1 is greater than term k plus 1 will be the greatest. Well, I've said term there, but I'm only interested in the coefficients for this particular question, so I'm not going to worry about the x's. So 20ck, 2 to the power of 20 minus k, 3 to the power of k, greater than or equal to 20ck minus 1, 2 to the power of 21 minus k, 3 to the power of k minus 1. There's the inequality that we have to solve. So 20ck, 20 factorial on k factorial, 20 minus k factorial, times invert multiply, so the other factorial becomes on the bottom now, 20 factorial, k minus 1 factorial, 21 minus k factorial. Again, the two have to add up to give 20, times, now I'm looking at the numbers. Whilst I don't know what k is, if I've got 2 to the power of 20 minus k and 2 to the power of 21 minus k, okay, I don't know what k is, but I do know that the power of 21 minus k must be bigger than the power of 20 minus k. So I know that'll cancel and leave 2 on the bottom. And then with the 3's, I've got to the power of k and the power of k minus 1. In this case, power of k would be the bigger one. They would cancel and leave 3 on top. Now I've got to do a similar thing with the factorials. Well, the easy one is the 20 factorial will cancel with the 20 factorial, so that's nice. K minus 1 factorial on the top, k factorial on the bottom. Again, which one is bigger? Well, the k factorial must be bigger than k minus 1 factorial. K minus 1 factorial will cancel into the k factorial, leaving me with k on the bottom. And then 20 minus k factorial would cancel into the 21 minus k factorial. 21 minus k factorial would be bigger, leaving me with 21 minus k on the top. And now I've got a nice little inequality to solve. So 63 minus 3k is greater than or equal to 2k. K has to be less than or equal to 63 on 5. Now I want the first whole number, remember k has to be a whole number, that is less than or equal to 63 on 5. In this case, k is 12. Now remember, we said term k plus 1 would be the biggest. So our greatest coefficient, because I'm not interested in the x parts, would come with term. So that's greatest coefficient. Greatest term, well, you can't find the greatest term unless they give us a value for x. Because depending on what x is equal to, it's going to change the size of the terms. So they'll usually accompany this with when x is a certain number. In this case, x is a half. So my general term, I'll substitute in, x is a half. And really it becomes the same question now as the greatest coefficient. So term k plus 1 would be 15ck. The 4 would be to the power of k. And the 3 on 2 would be the power of 15 minus k. Notice I didn't worry about the negative for this question. Because we're going to be comparing two consecutive terms. That's what we're really doing. We're saying when term k plus 1 is greater than or equal to term k. Now one of those is going to be negative and one of those is going to be positive. So clearly the positive one, if I was worried about plus or minus, the positive one would always be the biggest number. But what we're really talking about is the biggest in magnitude. We're not worried about the plus or the minus. So that's why I haven't bothered with the negative there in my general term. And I'll need term k. So 15c k minus 1, the 4 will be to the power of k minus 1. They've got to add together to give 15. So 3 on 2 is to the power of 16 minus k. So same idea, okay, term k plus 1 greater than or equal to term k. There's my inequality to solve. I'll divide by the right hand side. Now let's just play with this expression. So the factorials, 15 factorial and k factorial, 15 minus k factorial, times, invert and multiply, 15 factorial, k minus 1 factorial, 16 minus k factorial. Now, I've got 3 on 2 to the power of 15 minus k, 3 on 2 to the power of 16 minus k. 16 minus k would be the biggest, so I've got 3 on 2 on the bottom of the fraction. 4 to the power of k on 4 to the power of k minus 1. Power of k would be the biggest, so I've got 4 on the top of the fraction. So 4 divided by 3 on 2, which I can tidy that up to be 8 on 3. Now the factorials, 15 cancels with the 15 factorial there. Again, k is bigger than k minus 1. So I'm left with k on the bottom. 16 minus k is bigger than 15 minus k. So 16 minus k will be on top. There's my inequation to solve. We're looking for the first number less than or equal to 128 on 11. So k would end up being 11 for this one. So substituting back in, term 12 would be the biggest. 15c11, 3 on 2 to the power of 4, 4 to the power of 11. Again, I would normally leave this unsimplified. However, there is some simplifying that I will do because 4 can be rewritten as 2 squared. So I can tidy that up a little bit. If I make 4 2 squared, that becomes, instead of 4 to the power of 11, it'll be 2 to the power of 22, which will cancel with the 2 to the power of 4, leaving me with 2 to the power of 18. That's a little bit neater than having that fraction there. Okay.